Okay, so now we have some tools under our belts for solving systems of equations. We can graph them, use our calculators, find the intersection. That's definitely something we have to know how to do. There will be questions when that's how we do it. And we also have the substitution and elimination methods to solve systems of equations. So again, you're going to have to learn how to do those. Okay, so the very first word problem we ran into involved the life expectancies of men and women. We were given this table, right? And what this means was a baby born in 1980, if it was a female baby, we would expect that that baby was going to live to see 77.4 years of age, right? Statistically, on average. Whereas a man had a life expectancy of 70 years of age, statistically, on average, right? Some people die much younger, some people will die much later. This is sort of the average. So what we did is we created a scattergram between the two. Then we found the regression lines, and the regression lines were these. So we used our calculators to find these things. And then we used the calculator's graphing function, calculate the intersection between the two. So we found that the answer was something like this. We found that 81 years after 1980. So we found that the answer was like 2061, I think, is when men and women will first have the same life expectancy. So a baby born in 2061 will have the same life expectancy regardless of whether it's a boy or a girl. And that life expectancy, we estimated it to be about 86.81 years of age. That's how we found it with our calculator. But now we get to maybe explore how we would have found something like that with just using the substitution method. So if we didn't have the graphing calculator to help us, what we would do is rewrite each of these with a y. So here are our two equations. So of course, if we didn't have a graphing calculator, we wouldn't be able to use the regression function to find these things. So they might be given. So we have w of t given as 0.115 t plus 77.44, and then m of t equal to 0.20 t plus 69.80. Okay. So what we would want to do is maybe use either the substitution or elimination method. Remember, sometimes I like to express this as an ordered pair A and B, right? I know that when I graph these things, they're going to look something like this. And there's a point right there where they both cross. Some A, comma B, that's what I'm after. That's what I'm after, is this ordered pair A, comma B, like this, and like this. Now this is going to be a t value, and we describe t to be the number of years since 1980. Number of years since 1980. So we got to keep that in mind. And we're after that. Now I already know the answer because we solved it with the graphing method. But we're going to solve it using the substitution method. Now, what should we make this axis? Should we make it w of t? Should we make it m of t? Well, for the purposes of this, I would say just think about it as a y. It's just the output, whatever it is. This isn't always equal to that, which is why I like to go back to the variables of a and b. We're saying at the point where they intersect, then they're equal to each other. Just at that point, right? At the point A, comma B. At that point, this is a special choice of t. It's an input value, which we already know it's like 80 something, right? 81. That's what we're trying to discover. But at that point, this and that are the same for both equations. So the top equation would lead to having b equals to 0.115 a, right? When I input a years, then I calculate all of this and I get the life expectancy of women, and it's equal to some value b. And for the men, it's going to be the same thing. B equals to 0.208 at A plus 69.80. So we get that system of equations. So it looks a little nicer than the function notation style, right? And it makes sense that at that point, they're going to be equal to each other. Any questions so far? No? Very subtle distinction here, right? This is a function where you input any t-value and the answer is the life expectancy of women born that many number of years after 1980. So like I could input t equals to 7. And the answer to all this would be the life expectancy of a female baby born in 1987, right? Here, this is the life expectancy of men. It's any t-value you input results in some output that gives you the life expectancy of men at t years since 1980. So if I input it like 13, then I calculate all this, the answer would be the life expectancy of males 13 years after 1980, so the year 1993. This is a little different here. This isn't any A, any B. This is saying at the point where they cross, at this intersection point, A represents one unique number. It's not any number. You don't get to choose it. It's not an independent variable. It's a constant. It's a value. We just don't know it yet. If there's only one number out there, it turns out it was like 80 something, right? But this is representing a unique number. So for that reason, we can solve this by using either the substitution or the elimination methods. Based on the way they look, what would be better? Substitution or elimination? Substitution. Okay, so I'm going to set this, which is equal to B, equal to this. So I'm going to put it this way. 0.115A plus 77.44 equals to B, which B is also equal to 0.208A plus 69.80, right? So B is equal to that, and B is equal to that. So I just rewrote it this way, equals B, which equals B, right? They both equal B. So in fact, I just don't need that middle part anymore, right? They both equal to B. So this would be 0.115A plus 77.44. They equal each other, so they equal to 0.208A plus 69.80. Okay, so now we can easily solve this. Move all the A's to one side, move the constant to the other side, and then divide by the numerical coefficient of the A. So I'm going to move this over there. I'll end up with 77.44 equals to, and I'm going to subtract 0.115 from 0.2, in fact, let me minus 0.115A minus 0.115A. So these guys cancel. What do I get there?
0.093.
0.093?
Yeah.
Okay. At the same time, I'm going to subtract 69.8 from there. That'll cancel. Subtract 69.80 from there. What am I going to get?
7.64.
6.4?
7.64.
7.64. 7.64. Good. And then finally divide everything by the 0.093. So 7.64 divided by 0.093 is going to be the value of A. What do we get? A should be 8182 equals to A. Good. Any questions? Any questions? Any questions? So that matches with what we thought from before, right? This guy is 81.82 right in there. And now, to find the value of B, I can just plug it into either equation. Good. So, say for instance, I use this top one. So B equals to 0.115 times 81.82, the value of A, plus 77.44, and I'll get that B equals to 86. Oh wait, they got 81. Are we sure about this?
I got it too.
Oh, it's because of the rounding issues that we did, right? So you guys got a different answer for this one? 82.15. 82.15. Yes, that's what people are getting?
Yes, I got it.
Okay. 82.15. And then that means that this guy is 82.15. 82.15. And then what do you get for this then?
86.88.
86 point what? 88. Okay, so we're getting slightly different numbers than before. That's just because of rounding issues. 86.81. Good. So we're getting that a baby born 82 years after 1980, that would be the year 2062. In the year 2062, we expect that both male and female babies born that year will have the same life expectancy of 86.81 years. Right? That's what we're getting. This is the ordered pair, 82.15, comma, 82.81. Good? Any questions? Any questions? Okay, so now let's take a look at this one. In 2012, a 2011 Acura RL cost $37,120, and a 2011 Chevrolet Impala LS sedan cost $14,050. The RL depreciates by $4,245 per year, and the Impala depreciates by $1,200 per year. When will these 2011 cars have the same value? Okay, so this is a more interesting one. So the value of these cars is obviously depreciating every year, right? It's decreasing. So we started some original price, right? You buy it brand new off the lot. As soon as you roll off the lot, it starts going down in value, right? And if they're telling you that the RL depreciates by $4,245 per year, that lets me know what kind of characteristic is true about the rate of depression, the model that describes the value of the Acura. The model must be if the value goes down by the same amount every year, then we know that it is linear, right? Yeah. So because it's going down by the same amount, right? It's consistent. Some of you guys were talking about this, you know, that's really the slope, right? It's a consistent slope. It's a consistent rate of depression. It's a consistent rate of change. All these things that let me know that I'm going to get a linear model. If it said something, you know, could be more complicated, as we'll see in the next few chapters, things can get a little more complicated. For now, it's a consistent rate of change. So, how should we tackle this thing? Well, there's a variety of ways to do it. For one thing, tables are always a great way to organize the information given to you. So, you might want to do a table. So, let's see, for the Acura, RL, well, also keep in mind, what is $37,120? Is that the price of the Acura brand new? It doesn't say, right? It says in 2012, a 2011 Acura. So another way of just saying that is that in 2012, a 1-year-old Acura RL is $37,120. I mean, it's already 1 year old at that point, right? That's what they're letting me know. Okay. So that's something we know about the Acura. What else do we know? We know it depreciates by $4,245 per year. So I know that ultimately I want an equation that gives me the value is the answer, and then the input, right, it's going to be the input, well, let's put it this way. I'm looking for a linear equation, y equals mx plus b, right? I know it's going to be a line. We decrease consistently. And I know that means that the slope must be negative 42, 45. Okay? Because it's going down by that amount every year, all the time. And then this. Well, for one thing, I'm going to change the letters around a little bit. Instead of x's and y's, I'm going to use t to represent years after a starting point, and that's something we're going to have to pick. So I'm going to make this r of t. Well, I'll leave it for y, as a y for now. Okay, so I'm just rewriting that this way, and now we have to choose what the t means then. So if we're going to let it be t, t represents the number of years from a starting point. So what should that starting point be? We got two options available to us. So when I graph this, ultimately, I'm going to have some sort of t-axis that way. Am I going to let t be equal to the number of years since 2011 or 2012? Both of them have some advantages and disadvantages, as we'll see. They're both right. It's just a matter of what you choose, and be consistent with your choice so that you can get the answer some of these questions properly. So if you choose 2012, if you choose that, then what's the advantage there? When you're trying to solve this, well, if that's the number of years since 2012, isn't this the value of this car in 2012? Right? It's already 1 year old, but in 2012, this is the value of it. So that means that this y-intercept over here, here's like the equation that describes the value of this Acura. That means that this y-intercept is 37,120. Right? It's the y-intercept. That's what happens in 2012. It was that. However, it is not the price of the car when it's brand new, because the brand new car is from 2011. So if you make the choice of making that 2012 there, that means that -1 is a valid point for you. -1 would represent the year 2011, which means that where this graph crosses there, over there, this right over here would be the price of the new car. Price, MSRP, MSRP of new car. So you just have to be careful to input the -1 if they ask you that. And also some other phrasing, like if they said, what's the price of the car when it's 5 years old? Well, when it's 5 years old, you don't input 5 because new was -1, so a 5-year-old car would be at 4. Right? So it just kind of messes with the way you have to answer things. So for that reason, I don't like it. But it's not a wrong choice. You just have to be careful of what you do. Does that make sense to everyone? Yes? Yes, yes, yes? Okay, so instead of choosing 2012, I'm going to choose to define my t-values as the number of years since 2011. I like it better that way. I know that it's probably a little easier to get this equation right now if I set it as 2012. Since it already gives you the intercept point. But the advantage of working with 2011 is that down the road, when there's lots of different questions, it'll make it more intuitive to define the t-value this way. Okay, so if I define that to be 2011, this is no longer equal to this. That's not true. Now this is the point 1 comma that, right? So now, since we defined it since 2011, negatives are no longer allowed. 1 right in there is the year 2012 now, which means that they've given me this point on my line. They've given me the point 1, comma, 37,120. Comma and comma seem kind of weird, so I'm just going to leave it without the comma. 37,120. Is that clear? Any questions about that? So if I define it this way, I no longer have the y-intercept. So it's going to be just a little bit more work for me to find the y-intercept. Now it's actually not that bad. You can do it in a couple of ways. What's one way to figure out what the y-intercept is? I could just add what?
4,000.
Yeah, I know that I lose this amount of money every year, and I know this car is 1 year old, and after 1 year it's equal to this. So all I have to do is add the value I lost the first year. So MSRP, the value of the car brand new, should be equal to 37,120 plus the 4,245 that it lost in value that first year. Right? So that takes us to what? 465? 365. $41,365. That is the intercept. Good? Okay, that's one way to do it. Another way to do it, to organize all this, if you're still kind of fuzzy about what's happening, is that you can just organize a table. Right? We have input values of t, and again, describe what you mean by your t. T since 2011. So t equals to 0, this means this is the price when it's new. Right? And then 1 year later, well, okay, we know that 1 year later it was 37,120. I know it loses $4,245 every single year. I have my calculator. So I know that it loses, from there to there, it's going to lose 4,000. It's going to lose $4,245 from this step to this step. So 37,120 minus 42,45. I know the next one is going to be 32,875 after 2 years. And then I can go backwards to figure out that up here, when it was new, it must have been $41,365, right? And so this is the value of the R. So I'm going to use R of T to represent the value of the RT, of the RL model. Good? Good, good, good. Okay, so for all those reasons, we can figure out that this equation becomes y equals to negative 4245t plus 41,365, or we can go back to function notation and rewrite this as r of t equals to negative 4245t plus 41,365. Good? Questions, 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 questions? Okay, all that work was just to figure out one model, right? This is an equation where you tell me how many years old is the car. Since we set it equal to 2011, then we could just say how old is the car. Is it 1 year old? Is it 2 years old? A 2011 model, at least. A 2011 model, after being 2 years old, 3 years old, you plug that into here, and then the output is the value of the car. Good? Okay, so now we got to do the same thing for the Chevrolet Impala. So let's organize the information we know for that one. So the only thing that's really important is for you to define your t-value the same way in both cases. If you chose to use 2012 for one of them, just make sure you use the same one for the other one. You don't want to mix and match them, because then it'll get extra complicated to figure out where they cross, and it's just going to be ugly. So just be consistent. In the previous one, I decided to make it 2011, so we should do the same thing here. There is going to be some sort of a linear equation that looks like that, That's decreasing, right? This is when they bought it brand new. That's what we want. It's going to be t equals to the number of years since 2011. So it does something like that. We don't know that value there. We do know that 1 year later, this Impala had a price of $14,050. Right? It was 1 year old in 2012. This is some sort of Y value there. This is some sort of a T value there. Okay, so for the Chevy, we know that in 2012, a 1 year old Chevy was valued at 14,050, and we also know that it depreciates by $1,200 every single year. That means it's a linear equation. That means I know that this will be the solution, y equals mx plus b. We know that our m is got to be negative 1,200 because that's what it loses every single year. Right? Consistently, it drops by $1,200 every single year. I'm going to change this letter here to t, defined as that over there. And now I have to find the value of b. So just like before, we can organize a table to see some of these values if we want to. So let's say we put t in here, and let's call this c of t for Chevy. So I don't know what happens at 0 yet. That's I want to find that out. That would mean the price of the Chevy when it's brand new. I do know that when t is 1, this is 14,050. And I do know that it changes, it loses $1,200 in value every single year. So I know that the next year it's going to be worth what?
12,850.
Good. And I know that the year after that will be equal to what?
9,650.
Right? And I know the year after that will be equal to
10,450.
right? It's consistent, right? Every single year it drops by $1,200. It drops by $1,200. So I can use that idea to go backwards and realize that that must have meant that this thing brand new was 15,250, right? Because it keeps losing $1,200 every year, and this is a 1-year-old car, so it must have been $15,250 brand new. So that's our y-intercept on here. On here, this is the point 0, 15,250. Right? It's the price of the car when it was new. Good? Questions, comments, issues? No? 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 Any questions? Any questions? Any questions? Questions? Notice, by the way, that if you had not realized that this is the slope, and maybe you just did this, I mean, it sort of goes kind of hand in hand. You kind of have to know that the slope is the constant rate of change in a linear equation, which means that that's why it goes down by 1,200 every time. So just knowing that should let you know that that's the slope. But even if you weren't quite sure, or maybe this just table was given and nothing else, well then we could still use our slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 3, on any of those, and the answer will be exactly 1,200. Right? So for instance, if I just chose, let's say I chose this point and that point, then I could say that 12,850 minus 10,450 divided by 2 minus 4. What did I do? Yeah. This is going to be equal to negative 1,200. So the slope formula gives us the negative 1,200 from the table, if you don't see it. Okay, and now we just discovered that the y-intercept must be equal to 15,250. So this is y equals to negative 1,200 times t plus 15,250. And then again, I can rewrite this in function notation that say like c of t equals to negative 1,200 t plus 15,250. Good? Okay, so this is an equation that models the value of a 2011 Chevrolet Impala, where T is the number of years after 2011. In other words, it's how old the car is. So when it's 1 year old, 2 years old, 3 years old, we input the number of years, how old it is, and this thing, boom, boom, we tabulate it, and the answer will be the value of the car. Good? So if we input 17, it'll be the year 2028, right? If this guy was 17, it's the number of years after 2011, so it'll be the year 2028. So if I input 17 in there, it'll tell me what the value of the car is in 2028, approximately, right? Will we ever get negative numbers? Yeah, remember the math equation sometimes goes beyond the scope of what the model is valid for, right? So the model is bound to break at some point and start giving us silly answers. Okay? All right, so now we have both models. Now we can finally answer the original question, which was, when will these 2011 cars have the same value? Okay? That's ultimately what we wanted to answer. So let's put it all together over here. We have C of t is equal to negative 1200 t plus 15250. That was the Chevy model. And then we had this one, which was, say, R of t. This is the Acura one. It was negative 4245t plus 41,365. So here's our system. We finally discovered this system of equations, right? You give me a t value after 2011. They were both defined the same way, so that's what's nice. They have to match. If you chose 2012, just make sure you did the same for both. Or in our case, we chose 2011. They're the same for both. So when I graph them, I will see that one of them kind of looks like that, and the other one kind of looks like that. Right? We'll use our calculator to graph them in a second, but we also have to learn how to use the substitution and or the elimination method to solve it. So there is a point right there, A, B, where that A comma B is the solution to this system. That's what we're after. There is a particular year, a particular choice of T that will end up giving us the same value for both cars. Good? Alright, so at the point A comma B, we end up with B is the answer when negative 1200 times A plus 15250. And for the other one, B is the answer when we have negative 4245A plus 41,365. Good, 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 good. Okay, so now we can either use the substitution or the elimination method. Substitution method. Okay, they both equal B, so we can set them equal to each other. Negative 1200A plus 15250 is equal to B, and then B is also equal to this, so I'm just going to set it equal to 4245A plus 41,365. Okay, so I'm going to solve for A. I'm going to add plus 4245A to that side, plus 4245A to this side. What do I get? 3045. So 3045A. And then I'm also going to subtract 15250 and minus 15250. So here it'll cancel. I'll end up with this equals whatever that is. And what's 41,365 minus 15,250? 26 what? 115. Okay. 26,115. So now all I have to do is divide both sides by this, and I get that A equals to 26,115 divided by 3045 means A equals to 8.576. Let's go with 8. So about that. So that means that this is equal to 8.58. Okay? And so now we just have to find the value here, the resulting value, which is the value of the cars. How much were they worth? I know that about 8.5 years after they're brand new. What year would that be? In the year 2019. In 2019. Now, you know, some books ask you, sometimes they ask you to round to the nearest year. This is going to round to 9, so I would either accept in the year 2019 / the year 2020. One of those two would be a good answer. And what is the value going to be? Well, you can take either one of these, it doesn't matter which one, and now plug in your new value of A. So B equals to negative 1200 times A, which is 8.58, plus 15250, and we get that B equals to what? 4954. Okay, there we go. So this is saying that in the year 2019, 2020, the value of the car, of both cars, is going to be about 4954. $4,954, right? So this is 8.58, comma, 4954. Okay? So now, keep in mind that the way we interpreted this was by keeping our definition, which was T was the number of years. The number of years since 2011. That's how I defined it to be. That's why I get an 8.58, which comes up to this. Now somebody else could have chosen 2012, right? If you choose 2012, what's going to be different? Well, first of all, these two things are going to be different, right? Because you would have used the value in 2012, which was the ones that were given in our ordered pair. So, for instance, if you had chosen that, you would have gotten, that's ugly. Come on, give it to me. Whatever. You would have gotten that for the Chevy Impala, this would have been the 14050, because that would have been the y-intercept if you had used 2012. And for the RL, this would have been the 37,120, because it would have been the y-intercept. And also, when they crossed, well, you would have been off. And you would have gotten an answer of 7.58 here. And then when you interpreted the year, well, keeping in mind you chose 2012, that's how you would have gotten to the same answer. So you still would have gotten the same answer, it's just the numbers would have been just a little bit different. Got it? Good. So your systems of equations would have been something that looks like this, where this is, keeping in mind it's the year 2011 for us, and 2012 is how the t's were defined. And then when you graph them and you get the intersect, the input value looks just a little bit different because it gets interpreted a little bit differently. But ultimately, the final answer is always the same. Any questions? No? 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 Okay, just a few more minutes. Why don't you do it real quick with your calculator. Let's just verify that it's true. Input this into your calculator. Y sub 1, Y sub 2, graph them, find the intersection, and confirm that would have gotten something close to this. Okay, so you turn on your calculator and you'll, find yourself in some random screen sometimes, or, you're in the main screen but there's information from a previous question or something. I like to clear it, get started, new slate, new question. Okay, so I'm going to go over to y equals. If there are other equations on there from a previous problem I don't need, I'll get rid of them, clear prior things. Okay, so for y sub 1, I'm going to type in negative 1200. Make sure you use negative down here, not the subtraction symbol. That'll give you an error. This is subtraction, this is a negative number. Okay, now x. Remember, our calculators only use x's and y's, so even though our word problem involves c of t and all that, Here, it just does x's and y's. So the x is over here. We're going to push this button. Then plus 15,250. And then down. And then the other one is going to be negative 4240. Oh, I'm sorry, 45. 4245, negative 4245x. It's this button right here. Then 41,365. There's both of our equations. Now, notice how this plot 2 is dark up here for me. That means that plot 2 is active. Remember, the plots are the little dots. When we go to the list and try and input a table and graph dots, that's a problem because I don't want to do that. I don't want to graph those scattergrams. That's going to cause a problem. So you can either go to stat plot like this and go in there and turn it off, or from this screen, there's a nice shortcut. You can use our arrows to go up there, get to it, and then hit enter, and then go away. And see how it's no longer dark? It's been deactivated. I don't have a danger of getting an error from that. Okay, good. Now I have to go to window and pick a good window. Now you got to think about your input values. The input values are years that the car is, the value of the car. Do I care about the value of an Impala 75 years after it was bought? Probably not in most cases. And especially the value of this model is assuming sort of the standard result that values depreciate. So maybe I only care about, say, the first 20 years, right? Most cars are good within the first 20 years, or they have some numerical value within the first 20 years. What about the actual values? The most expensive is when the Acura RL was new, which is about 41,000. So I'm going to go to Window, and I'm going to choose from 0 to 15, and the output values, I can go from, say, 0 to 45,000, and that should do a pretty good job of sketching it. So there's that one, and then there's that one. And yep, there's where they cross right there. So that's what I'm after. I'm after that intersection point right in there. And if I hit calculate, so I have to hit second, calculate, intersection, which is the 5th option down. You see how all the writing kind of covers it? It's just the style thing. So to do this, I'm going to go to make myself some room so that the writing doesn't overlap where the graph is. I'm going to go back to window, and even though it doesn't make sense to have a value of the car to be negative, I'm going to put a negative, say negative 10,000 on there, just so that when I graph it, I have some space down here. See, I have a little bit of room down here. Now, when I hit calculate, it just won't overlap it, and I get to see what's happening. So the 5th option down for intersection. Okay, now it's a little better. So enter, enter, and then use your arrows to get kind of close to it. Enter one more time, and we're home. Okay, so we get the same result. Any questions? Any questions? All right.